Dear students, welcome to EPG Pathshala. I am Deepika Goswami, working as scientist in Food Science and Technology in the Food Grains and Oilseed Processing Division of ICAR, Central Institute of Post Harvest Engineering and Technology, Ludhiana. As we all know that wheat flour is the major ingredient of the bakery products. It constitutes up to 55 to 60% or more as a ingredient in almost all the bakery products. Hence, it is rightly termed as the major ingredient in the baked products. So, in the present module, we will cover the wheat, the different types of wheat flour which are commercially available, the function of wheat flour as a baking ingredient, and as we also know that the wheat flour is always not suitable for the baking purpose. Hence, there are certain functional ingredients which are used to enhance the baking quality of the wheat flour, and these are termed as the flour improver. So, here we will cover the different types of flour improvers, their mode of action and the role, the function they do while baking. Apart from these, the last but not the least, we will also cover the role of water in the baking. The different baking ingredients can be categorized as major, minor and micro ingredients depending on the level of usage in formulations. The major ingredients, these constitute 55 to 60% or more of the formula weight, and wheat flour is the major ingredient. Those ingredients which are used in the level of 5 to 10% of the formula weight are categorized as minor ingredients, and leavening agents, dairy products, starches and egg, these are the minor ingredients of the baked products. Now, the last one is the micro ingredients. These are used in micro level, that is in parts per million ppm, usually ranging from 0.1% or less to 5%. Besides these above mentioned ingredients, there are some which are used for their attractive attributes and are called as characterizing ingredients. Wheat flour is the major structure forming ingredient in baked products, which is obtained from the milling of wheat, one of the most important cereal crop in world. This crop belongs to the genus Triticum of the grass family Gramineae. The wheat kernel is composed of three parts: the outer bran layer, which forms the hard outer coating of the kernel, the smaller germ portion that includes the embryo and scutellum, starchy endosperm that act as a reservoir of food for the germinating embryo, and wheat contains 10 to 13% protein, 1.5 to 2% fat, ash and fiber. The different wheat protein fractions are as follows, and these are categorized depending on their solubility. The water soluble fraction albumin, globulin, which is the salt soluble fraction, glutenin and gliadin, which are soluble in dilute acid and alkali, and 70% ethanol respectively. Besides these protein fractions, proteases also account for 2.5% of wheat protein. The protein content of wheat grains varies from about 7 to 17% depending upon the variety, soil, climate and weather. The commercial wheat flour, it is obtained from two types of wheat, hard wheat and soft wheat. Hard wheat, it has a high protein content and the yield of flour is also good. The dough formed has high water absorption capacity, strong gluten network, elasticity and excellent gas holding capacity. Due to these mentioned characteristics, hard wheat is desirable for bread production. Now, another one is the soft wheat, which has a comparatively lower protein content, and the dough formed has poor water absorption capacity, poor tolerance to mixing and fermentation. Although soft wheat flour is undesirable for bread, but for cakes, pastries and cookies etc., where a tender product is desirable, soft wheat flour is required. Now we come to the role of gluten. When wheat flour is kneaded with water to form dough, the protein fractions glutenin and gliadin. These interact with each other and form gluten, which has the characteristics of both stretchability and elasticity. For proper gluten development, glutenin and gliadin should be in a ratio of 1:1 in the flour. That is why wheat flour, where there is a 1:1 ratio of glutenin and gliadin, has the most important role in bakery products. When the dough is allowed to rise, the leavening gases are formed and expanded, which are trapped by the gluten network. The gluten will continue to stretch as the gases expand during heating until the heat of the oven coagulates the gluten. This process results into a spongy texture of the baked product. There are certain commercial grades of wheat flour which are defined by how much pure endosperm is there. High endosperm flours are whiter in color because they are relatively low in bran and germ, and these which are considered undesirable in baked products. Although these are considered as high quality flours, due to the high baking quality, they are lowest in nutritional quality. The traditional way for manufacturers to confirm the grade of flour is to measure its ash content, which is highest in bran, hence indicating the amount of bran in flour and therefore of the flour's commercial grade. The following are the commercial grades of flour. Patent flour. Patent flour is the highest quality of all commercial grades of white flour, as it consists of the innermost part of the endosperm and is essentially free of bran and germ. This makes patent flour lowest in ash and whitest in color. It is often used by bakers for manufacturing bread, pastry, cake. Patent flour is made by combining the first few streams of flour from the milling process. These are also graded depending on which stream of flour from the milling process are blended. The highest quality patent flour is called extra short or fancy patent. The another grade is clear flour. It is the lowest quality of all commercial grades of flour, as it consists of the outer part of the endosperm and contains germ and bran. The flour streams that remain after patent flour are the clear flour. All clear flours are relatively high in bran, high in protein and ash, and slightly grey in color. While it is higher in total protein than patent flour, the gluten formed from clear flour is typically of less quality than that from patent flour. Hence, clear flour is less expensive than patent flour. Straight flour. It is milled from the entire endosperm. It is made by combining all usable streams of flour from the milling process and contains bran and germ particles that are not easily separated from the endosperm. There are certain types of patent wheat flour. Most flours purchased by the bakers are patent flours milled from the heart of the endosperm. The differences among the various patent wheat flours are due to the type of wheat used in producing the flour and because of the differences in milling practices or additives. Bread flour. The flour used for bread making is generally obtained from hard wheat. It is high in protein, typically 11.5 to 13.5%, that forms good quality gluten, and maximum 0.4% ash. This flour should form gluten of necessary strength, stability, extensibility, and gas retaining property. It should also have sufficient damaged starch, which will act as yeast food during fermentation or proofing of the loaves. Sometimes it contains added malted barley flour to provide for better yeast fermentation, dough handling, and shelf life. Bread flour is typically used for pan breads, rolls, croissants, and sweet yeast doughs. Pastry flour. Pastry flour is ideal for cookies and many pastries that do not need rising and hence sweet, extensible gluten development in the flour. Pastry flour is milled from soft wheat, generally from soft red winter wheat, and is low in protein, that is up to 7 to 9% protein. For this purpose, soft wheat flour with lower protein content is used. Cake flour is milled from soft wheat. It has a high starch content and a very low protein content, that is 7 to 9%. Hence, it is not suitable for bread making. It is short or fancy patent flour, meaning that it comes from the absolute heart of the endosperm. This gives cake flour a finer granulation, white color. This flour should have good water absorption capacity. It is typically bleached with both chlorine and benzoyl peroxide, yielding a stark white color and a distinctly changed flavor. All-purpose flour. It is often made from a blend of hard and soft wheat and contains 9 to up to 12% protein. This flour comes bleached or unbleached and may contain added malted barley flour. It is mostly used in the food service industry like hotel and restaurants. There are other flours also. These can be categorized as white flour, brown flour, wholemeal flour, germ enriched flour, multigrain flour, organic flour, and the composite flour, depending on the component of wheat present in the flour. Whole wheat flour. When the flour contains all the three components of wheat kernel, that is bran, germ and endosperm, it is called as wholemeal flour. The nutritional composition of this flour is exactly the same as that of the wheat from which it is milled. Since the germ has a high fat content and fat can go rancid, these whole wheat flours are much more likely to spoil. Brown flour. The nutritional value of white flour can be increased by addition of selected co-product stream to it. Such flour is termed as brown flour. Germ enriched flour. White flour can be enriched with cooked germ to improve its flavor and enhance its nutritional value. The germ enriched flour should contain minimum 10% cooked germ. Composite flour. It is prepared by blending wheat flour with other flours like cereals, legumes, etc. to lower the use of wheat by partial substitution for economic regions. It has enhanced nutritional properties as compared to wheat flour. The increasing health concern and a growing consumer demand towards health food have led to the increased utilization of other nutritional cereals in the bakery products, which result into products based on multigrain flour. Hence, multigrain biscuit, bread, etc. are the most common sight at the grocery store, and these are having more consumer demand. These are made by incorporating other cereal flours such as maize, millets, barley, rye, etc. in the formulation in addition to the wheat flour. Although these flour formulations reduce the performance of baked products, but several research works have been extensively done to improve the quality attributes of multigrain bakery products. Gluten-free flour. In gluten-free flour, a complete substitution of wheat flour is done with other non-gluten containing flours. The gluten-free flour can be obtained from rice, millets, sorghum, cassava, etc. Plain or self-rising flour. This flour has also become popular in recent years and is made from fairly soft wheat containing 8.5 to around 11% protein, in which sodium bicarbonate is added in the form of baking powder at the mill itself. Hence, there is no need of addition of baking powder in home preparations. To summarize, the major function of flour in baking are as follows: structure building of the baked products, to absorb liquids. Starches, proteins and gums are the three main components in flour that absorb moisture and oil, helping to bind ingredients together. The absorbed water also helps preventing staling of some baked products like bread. And the another function is to contribute flavor. Wheat flours have a relatively mild, slightly nutty flavor that is generally considered desirable. To impart color, flours vary in color, whole wheat being nut brown in color, whole white wheat flour golden color, durum pale yellow color, unbleached white flour a creamy color, and cake flour a stark white color. These colors carry over to the color of the baked goods. These also add nutritional value. Wheat flour and flour-based products contain complex carbohydrates, vitamins, minerals, and protein. Whole wheat flour is more nutritious than white flour. There are certain flour improvers which are used in the baked products, and these are combined with flour to improve the processing and baking quality. These are also called as dough conditioners, dough improver, and bread improver. To increase the speed of dough rising, to improve the strength and workability of the dough, etc., these are some of the functions achieved by these functional ingredients. There are wide ranges of these functional agents used in bakery processing, which can be grouped as bleaching agents, maturing agents, oxidizing agents, reducing agents, enzymes, and emulsifiers. These are often sold as mixtures in a soy flour base, as only small amounts are required. The major flour improvers used in baking industry are as follows. Bleaching agents. The freshly milled flour is yellowish in color due to the presence of the xanthophyll pigment. However, in some baked products like white bread, white color flour is desired. So, bleaching of the freshly milled flour can be achieved naturally by oxidation when the flour is exposed to air, but it is not feasible for the flour under bulk storage. Hence, to accelerate the bleaching, it is treated with some bleaching agents. The most common bleaching agent used in bread and all-purpose flour is benzoyl peroxide, which brings out the change within 2 days. This is used in the form of dry powder. It does not have any adverse effect on baking quality of wheat flour. In case of cake flour, chlorine is used as bleaching agent. However, it is detrimental to bread flour. The another flour improver is maturing agents. Exposing flour to air for longer period, as in natural aging, causes whitening of the flour and strengthening of the gluten that forms from flour. Oxygen, the active ingredient in air, performs two major functions: oxidizing the carotenoid pigments in flour, changing their chemical structure and whitening them. And the another function is oxidizing the gluten forming proteins, allowing them to form stronger gluten. However, natural aging has few disadvantages also. That is, longer time requirement, often several weeks or months, which may cause storage problem. Due to the longer time, mold growth or infestation with insects or rodents, and inconsistent and lesser effective method of flour aging. Hence, a number of oxidizing agents are used as maturing agents to accelerate the aging of freshly milled flour. These agents primarily affect the sulfur containing amino acids, ultimately helping to form disulfide bridges between the gluten molecules. This helps in increasing gluten strength, resulting into a larger, more uniform finished product. These may or may not act as bleaching agents. The common oxidizing agents are various flour bleaching agents, azodicarbonamide, carbamide, potassium bromide, ascorbic acid, phosphates, malted barley, and potassium iodate. Another class of flour improvers is reducing agents. Reducing agents weaken the flour by breaking the protein network, which helps in handling a strong dough. The advantages of using reducing agents are increased extensibility, reduced dough elasticity, improved machinability, and shortened mixing and proofing time. The common reducing agents used in baking industry are as follows: L-cysteine, fumaric acid, sodium bisulfate, non-leavening yeast, and ascorbic acid. Enzymes act as natural catalysts to speed up reaction in dough or make reactions take place that otherwise would not. They include concentrated microbial enzymes in liquid powder or tablet form, and enzymes present in flour or malt syrup form. The following enzymes are used in improving flour quality: amylases, which break down the starch in flours into simple sugars, which further is used as yeast food, browning of product, softening and slowing stirring of the product. Malt is a natural source of amylase. Proteases, these improve extensibility of the dough by degrading some of the gluten. Lipoxygenases, these oxidize the flour. Another class is emulsifiers. Emulsifiers include natural lecithin and a variety of amphiphilic chemicals that are soluble at low concentrations in both oils and water. Some of these strengthen the dough and improve finished product volume by interacting with gluten, while others soften the crumb and improve shelf life by complexing with the amylose starch in flour to keep it from forming after baking. Emulsifiers can be used individually or in combination to achieve both strengthening and softening effects. Water. Water is an essential ingredient for bakery products. It can be added in the formulation either in its pure form or in form of liquids like milk, etc. For baking purpose, hardness and pH of water are important considerations, and hence water should have compliance as follows: medium hardness, that means 50 to 100 ppm, neutral or slightly acidic pH. Hardness greatly affects the dough quality, as too soft water results into a sticky dough and too hard water toughens the gluten and retards the fermentation that adversely affect the final baked product. The major functions of water are as follows: gluten formation. Gluten is formed during dough making only when the glutenin and gliadin protein interact with each other in the presence of water. To assist in control of dough temperature, hydration and swelling of starch for proper gelatinization during baking, hydration and uniform distribution of salts and non-flour ingredients, to act as medium for enzyme activity, to contribute moistness to the baked products and improve their mouthfeel. Natural leavening. Water and liquids present in dough turns to steam during baking, which causes the product to expand and hence contribute to the volume and tenderness of the baked products. So, dear friends, from the present module, we came to know about the different types of wheat protein and about the gluten, which is formed from glutenin and gliadin in the presence of water, its role in the leavening. We also came to know about the different types of commercially available wheat flour like patent flour, self-rising flour, straight flour, clear flour, etc. We also learnt about the different flour improvers which are used by the commercial bakers, that is maturing agent, reducing agent and oxidizing agent and the enzymes. At last, we also learned about the role of water in the leavening, that is the natural leavening, as well as in the gluten formulation.